Good morning, and welcome to the Maxwell Centre, where, if you haven't been here before, the coffee is very good, and not the stuff that's out there, but there's some better coffee above and below. And it's a building that is owned by physics, but its purpose is to act as a sort of meeting point for what goes on in the West Cambridge site, which goes almost right. So it's a building where meetings tend to work well. So I'm sure that will be the case today. So Svitlana is going to say something about the nature of our Simons Foundation collaboration. I'm on the fringe. That's to say, I'm an experimentalist and I work on organic semiconductors. Svitlana will say much more about the core underlying mathematical underpinnings of the program. But what's been interesting for us is that the landscape theory provides an approach to be able to explore just how localized or delocalized electrons or excitons, or particularly electrons, might be in the disordered semiconductors we work with based on molecular materials. So today we've assembled from the UK and nearby many from the community who work on the organics, in part experiment, but wandering into theory for electronic structure calculation. And tomorrow we move further into the core mathematics that underpins the landscape theory. So with that brief introduction, let me introduce Svitlana, who is the coordinator for the project, the owner for the project. So.
Well, it's fantastic to see you all here. Let me thank you for coming, for hopefully giving wonderful lectures, and for coming to listen to us. So, as Richard has mentioned, the workshop is a part of the activities related to the collaboration in wave localization. The collaboration sometimes sounds a little bit strange, but this is a sequence of actually very few projects supported at that scale by the Simons Foundation, devoted to a particular subject in mathematical or physical sciences. They fund one or two per year, and we have been lucky to be chosen by now a little bit over a year ago. The collaboration, the project is devoted to wave localization and actually much more generally to the behavior of waves in disordered or complex media, being from the point of view of geometry, from the point of view of material properties, potentials, and so on, disordered fractals, any sort of complexities in ambient medium which enforces strange or special behavior of waves is part of the study in this collaboration. We are quite widespread scientifically, meaning that the collaboration includes people in pure mathematics and applied mathematics, as well as theoretical and experimental physicists. So basically the only thing I would like to say in a few minutes that I have is to introduce the main players to you so that you have some point of reference. I'm a mathematician, a harmonic analyst by birth and training. These days I tend to do more and more of partial differential equations and collaborating with physicists as well, mathematical physics and so on, but my background is in harmonic analysis. Going from left to right, Marcel Filoche, who will be one of the first ones giving the lectures here, is specialized in condensed matter physics. Alana Spare should be coming a little bit later, I suppose. Haven't seen him yet. Is representing experiments with cold atoms and in particular the Anderson localization in cold atom systems. Richard Friend, well, you had a chance to hear, is one of the organizers of this meeting, working in organic semiconductors. Jim Speck should be coming a little bit later, working in gallium nitride, indium gallium nitride semiconductors. Claude Weisbush sitting over here, representing semiconductor physics. Doug Arnold, also one of the organizers of this meeting. Most of you probably have seen him already as well, representing the applied mathematics, the computational mathematics component of this project. David Jellison, whom I'm lost, but please, sorry. Right in front of me, also partial differential equations and harmonic analysis. Guy David, so there, harmonic analysis, geometric measure theory, some PDs these days, and Meyer, who is unfortunately not here, also harmonic analyst, probably most known for wavelets outside of the harmonic analysis community. And the consultants you see on the right hand side. So this is all to say that we are very widespread. We really go from pure mathematics all the way to very experimental physics. In the spirit of it, the meeting will be hopefully organized in such a way that the talks can actually address both audiences or many audiences represented in this group. And I'm very much encouraging you to ask questions, to talk to people, to be open to discussions. In such a wide representation, there are necessarily deep gaps in the background and so on, but hopefully it will be useful and exciting to all of you. So we are interested in waves and complex media more generally, and with that, let's start the meeting.